Hi everyone, welcome to my calculus lecture. In this lecture, we study inverse trigonometric functions. We first introduce inverse trigonometric functions, and then we will move on to the derivatives of inverse trigonometric functions. Okay, so let us start with the inverse sine function. As you know, y equals sine of x is not a one-to-one function, so it is not invertible. Not invertible means that there is no inverse function of y equals sine of x. So what do we mean by inverse sine function then, right? You know, although y equals sine of x is not one-to-one on the entire domain from negative infinity to infinity, however, if we restrict its domain, there's typo, I gotta fix this. If we restrict its domain to negative pi over 2, the closed interval from negative pi over 2 to pi over 2, it becomes a one-to-one function. Okay, so here the following figure shows you the part of the graph of y equals sine of x on the closed interval from negative pi over 2 to pi over 2. As you can see, clearly from the graph, this is a one-to-one function. Why is that a big deal? As you know, as you will remember, from algebra, right? If a function is a one-to-one function, it is invertible, right? So you can find the inverse function. So in this case, although the y equals sine of x is not a one-to-one function on the original, the domain from negative infinity to infinity, but on this restricted domain, right, across the interval from negative pi over 2 to pi over 2, right, it is invertible. Okay, so we can find the inverse function. Okay, so y equals sine inverse of x is the value in pi over 2 to pi over 2, right? Why is that? Because the original function y equals sine of x is defined, okay, on the restricted domain from the closed interval from negative pi over 2 to pi over 2. And you remember that the function and its inverse function, they swap what? They swap the domain and the range. So the domain of the original function y equals sine of x becomes the range of okay, y equals sine inverse of x. So sine inverse of x has values in this closed interval for which x equals sine of y. Well, this is also obvious, right? So the when you find the sincere, like I just mentioned, right? Original function and inverse function, they swap the domain and the range. So when we find the inverse function, what do we do? First thing we do is we swap x and y, right? So that's what we have, right? X equals sine of y, and then we solve it for y, right? Uh, but unfortunately, there's no like explicit form, right? Uh, that allows us to write, allows us to solve this for y. But we know that y exists, which is inverse function of sine of x. So, we write it as, the y equals sine inverse of x. But even if we know that we don't have an explicit way of writing down what the sine inverse of x is, it doesn't matter because, this is all you have to know, uh, the what is that? This relationship, right? X equals sine of y. So that allows us to find the values of y equals sine inverse of x, or later on, we find out that this inverse sine function is a derivative, so we can also find its derivative as well. Okay, so not a problem. Okay, so here, like the I'm going to stick to this symbol, right? The notation sine inverse of x for the inverse sine function. However, like if you look at like different textbooks or mathematical literature, right? Often people use y equals arc sine x. Okay, this notation also, right? And the other inverse trigonometric functions can be defined in a similar manner. Okay, so y equals inverse cosine of x is the value in 0 pi. So meaning that we consider the inverse cosine when the domain of y equals cosine x is restricted to 0 to pi. Okay, so from 0 to pi, you see that cosine function is a 1 to 1. So we can consider the inverse function for which x is cosine y. So same way. By the way, you might be wondering, right? Why like we choose like a particular domain for y equals sine of x, like the domain, the closed interval from negative pi over 2 to pi over 2, okay? Um, and for inverse cosine, we choose like, the domain like 0 to pi, the particular one, all right? I mean, there can be like other the intervals where like y equals sine of x or y equals cosine of x are 1 to 1, is 1 to 1, okay, is 1 to 1, and true. So that's the thing, if we don't, have an agreement on what the domain is going to be, people may choose like different domains, right? So, it's going to be quite confusing if that happens. So mathematicians, they chose to, right? They chose to use the closed interval from negative pi over 2 to pi over 2, okay? For the, the domain of y equals sine inverse of x. Likewise, they decided to use the closed interval from 0 to pi for the restricted domain for y equals cosine of x to consider the inverse cosine function. Okay? Right. So that's just convention. Okay. And y equals inverse tangent x is the value in the open interval from negative pi over 2 to pi over 2 for which x equals tangent y. And y equals inverse secant x is the value in this interval, okay? Close to 0, pi over 2, open cup, the open pi over 2 to pi closed, for which x equals secant y. In this case, the domain of y equals secant inverse of x is absolute value of x greater than or equal to 1. And y equals cosine inverse of x is the value in the half open or half closed interval, right? So actually closed, right? Negative pi over 2 closed, 0 open cup, 0 open pi over 2 closed, right? So on this in this interval, for which x equals cosecant of y. The domain of y equals inverse cosecant of x is also same as the domain of the inverse secant x, absolute value of x greater than or equal to 1. And lastly, y equals inverse cotangent is the value in 0 pi, the open interval 0 pi, for which x equals cotangent y. Okay, now we are moving on to the derivatives of inverse trigonometric functions. Like I said earlier, those inverse trigonometric functions are also differentiable, okay, are also differentiable. So we can speak of the derivatives of those, the inverse trigonometric functions. So let us first talk about the derivative of y equals inverse sine of x. Okay, so how do we find it? Uh, what happens is that by the implicit, remember, y equals sine inverse of x means that x equals sine of y. Okay, so although we don't have like explicit, the sine inverse of x is nothing more than just a symbol, okay, symbol to represent the inverse function of, the inverse of y equals inverse function of y equals sine of x, nothing more than that. So this alone, I mean, we can't find the derivative. However, this is same as x equals, right, equivalent. What I mean by same means equivalent, okay? So x equals sine of y. This one here, we know so well, okay? So we can find the derivative. So by assuming that y is a function of x, we can do the implicit differentiation of this, right? And that will allow us to find the y equals sine inverse of x. So to see that, let us move to my notepad. So here's a derivation of it. Okay, so uh, derivation of the derivative sine inverse of x. Okay, so what we do here is, right, okay, so y equals sine inverse of x is equivalent to saying, x equals sine of y, right? So we, by implicit differentiation, by implicit differentiation, the left side is 1. So we are taking derivative with respect to x, right? So right-hand side is cosine of y. And since y is a function of x, you have to multiply this by, dy by dx. Implicit differentiation is nothing other than the chain rule, right? If you remember. So we have to multiply by dy by dx. So now dy by dx is what we are looking for, right? Y equals sine inverse of x. So dy by dx, that's going to be 1 over cosine of y. So as far as the derivative is concerned, we are done, okay? However, we don't want to leave it like this because y equals sine inverse of x is a function of x, okay? So although we know that y is a function of x, we want to explicitly express, the derivative in terms of, x, right? So we gotta do a little more work on this, okay? So, going back here, x equals sine inverse of y, right? So, you know, you remember this well-known identity, right? So cosine squared of y plus sine squared of y equals 1. So you know the cosine squared of y is going to be 1 minus the sine squared of y. So cosine y is going to be plus or minus square root of 1 minus sine squared of y. In other words, that's a plus or minus square root of, the sine of y equals x, so 1 minus x squared. So this allows us to write down our answer, the derivative, in terms of x variable. But still there is a little thing we have to take care of, right? Because here we have two choices for the sign, plus or minus. Well, so which one to choose? Okay, remember, so the what is that? Y. Y is the domain of sine. Okay, domain of sine. Again, the original function and the its inverse function, they swap domain and the range. So in this case, the range for sine inverse of x is actual domain for sine, and the domain is restricted, to the closed interval from negative pi over 2 to pi over 2, right? Okay, so this is what we know. Since maybe I should just divide, okay? Right. All right, so since y is greater than or equal to negative pi over 2 less than or equal to pi over 2, right? Cosine of y is greater than or equal to 0. So that's, clear from the graph of cosine of y. Okay, so this means, our cosine of y is going to be positive. Okay, so positive square root of 1 minus x squared. Okay, so going back to this, right? So this will be 1 over square root of 1 minus x squared. Okay, so that's the formula. Okay, so therefore we found out that d by dx sine inverse of x equals 1 over square root of 1 minus x squared. Here, the further you have to be careful though. The x, right? X is the domain for sine inverse of X. We know what it is, right? The domain, the here domain is, let me use like a different color. Maybe I'm going to use this, right? So here, the domain for y equals sine inverse of X is actually the range of y equals sine of X. And you know what that is, right? Sine of X oscillates between negative 1 and 1, right? So here, the domain X is greater than or equal to negative 1, less than or equal to 1, okay? However, we have to exclude x equals 1 or negative 1 because those two, right, values of x would make the denominator 0, right? So here we are requiring that absolute value of x is less than 1, okay? Or equivalently, x is strictly greater than negative 1, less than 1, okay? Same thing. So that's what we got here, okay? All right. So in a similar manner, you can find, the derivatives of other, the inverse trigonometric functions as shown, right? The, the, the following, right? Okay, so this is it. A lot more details of my discussion in this lecture can be found in my lecture note at the following address. As usual, I made the hyperlink to this address. So all you have to do is click on this address to get to the lecture note. Okay. In there, like you will find a lot more details. As I mentioned, right, including like the nice graphics of like inverse functions. Okay, inverse trigonometric functions as well. Okay, and also if you want to visit my main blogger site, you just click on this word blogger, right, which also, the hyperlinked. Okay, so thank you for watching and listening to my lecture. Bye-bye.